Hello, and welcome to Lecture 3 of Statistics for Managers 333. I want to welcome you to the campus of my alma mater, Mount Vernon Nazarene University. This brings back a lot of memories. I'm here to ref a basketball tournament, and while I did, I want to take advantage of their whiteboard, because this lecture, I think, is very well demonstrated by picture. And this is your first lecture where you're going to experience a lot of formulas, and perhaps the formulas can seem a bit overwhelming. We see Greek letter sigma floating around. Can you see that? Sigma floating around quite a bit. And this is a summation notation, but if you're not familiar with it, it can be a bit intimidating. But what it means add up the items. Add up the items. Okay, so we're going to get to that in a second. Now, if you hear a bit of banging, it's because they're doing some construction upstairs. I apologize if it's distracting. Now, let's get started. The chapter starts out with a discussion about the mean, the arithmetic mean, or the arithmetic mean. And we're all very familiar with the mean. Well, I would hope. Based on your prerequisites for this class, I think that you should know that the mean is the average. The average is something we deal with quite a bit. If you're a fan of sports, the batting average for your favorite player. It means how many times we expect him to get a hit. So if his average is 0.33, we expect 1 out of every 3 times that he'll probably get a hit. You could get your average shopping bill for the month if you do groceries. If this week you have $100, next week you have $200, the week after you have $100, and the final week of the month you have $200. If you add them up and divide by 4, your average shopping bill should be around $150 for the week. Okay, and basically what you do, you take all the items in a list, you add up and divide by the number of items in a list. For instance, 100 plus 200 plus 100 plus 200 divided by 4. Okay, that's the same formula that's given in your book on page 97. If you look at formula 3.1, where it says x bar is equal to the sum of xi's divided by n. Well, let's break that down. Look, n is the number of times something occurs. And so here we have 4 weeks in a month. So here our n is 4. Okay, so we've got that knocked out. X bar, that's what we call the average, or the arithmetic mean, is x bar. We're going to remember bar, and I'm going to, you're going to know that that is an estimate. Okay, this is the first statistic that you've had in class. Okay, and I told you, I think in lecture number 1, that our statistics are added, and here we have one. It's called x bar. Yes, this represents the sample average. Now, the sum of xi, well, this I is a counter. Okay, it's a counter. It means how many items. Well, we know how many items. We have 4 items, and so we're counting up to 4. So week 1, week 2, week 3, and week 4. Okay? So that's how you read this. And so you would say week 1, this is week 1 plus week 2 plus etc. Okay? So the formula looks a little bit intimidating, but in our head we can do it quite easy. Yeah? $100 in week 1, $200 on week 2, $100 on week 3, $200 on week 4, divided by 4, and we do that, and we come up with $150. $150 is our average. Now, I spent a lot of time talking about average, but it's something that you already understand. But the reason I took that time is because you need to know that something so simple can look extremely intimidating. Okay? If you're left to read the textbook alone and to read my written lecture, that can be a scary concept. I've had people totally freak out on the arithmetic mean, and it's one of the easiest concepts that we're going to go over. Just because it's the first time you're going to be hit with that summation notation. That summation notation. Now, I think I'm going in and out of focus. So I'm going to pull this over just a little bit so my camera has some hard lines to focus on. The all-white blackboard is messing up with the autofocus. Now, listen. The mean is simple. Yes, but the mean is primary. It is absolutely primary to understanding statistics. My favorite professor at Ohio State University said he made his first $1 million on the mean and the standard deviation. Standard deviation is going to be coming up here in just a few minutes. But he said he made his next $12 million on the mean alone. Okay? He's a consultant, a very high-powered consultant for some major Fortune 500 companies. And he said that we could stop right now. And you would know enough to consult Fortune 500 companies on what they're doing wrong. Why? A lot of what statistics is looking at the mean and comparing how far we are from the mean. That's your first question when I give a test. Every time people ask me, what's the mean? What's the mean? I want to compare myself to the mean. I want to know, did I do better than average? Did I do worse than average? Did I do average? Okay? Now, we're going to look today on different ways of measuring items. Okay? We're going to get to some very technical ones in the end, but it's all going to go back to the basic principle of the mean is the center. And we want to see how far we are from the center. Now, you're going to read in your book and see that what we call the mean, the mode, the median are measures of central tendency. That's, again, more intimidating than it needs to be. It's just the center. Now, the mean, you can also think of the balancing point. Okay? This marker, let me get closer. This marker has a balancing point. Okay? Well, it should be right about here. Okay? That's the mean of my marker. Yes? Everything has a balancing point. You have a balancing point. I have a balancing point. Yes? Now, not everything balances in the center, right? Just think about back to playground when you're on the teeter-totter. You remember some kids had to move the fulcrum or the pivot of the teeter-totter over so that they would evenly balance out. I was a pretty tall kid. I was a little bit bigger than most of my classmates. So they would move the fulcrum a little bit closer to me so that they could use leverage to balance with me, yes? Well, that same principle holds steady in statistics. You know, the mean is going to move if the heavy part of what we're looking at is at the beginning of the set or at the end. For instance, what if in the beginning of each month you did a lot of bulk food buying at Sam's Club? So at the beginning of each month you spent $900. Okay? $900. And then the next 200, and then 100, and then 200. Take a second and see if you could figure out what that mean is going to be for the month. 900 plus 200 is 1100 plus 100 is 1200 plus 200 is 1400. 1400 divided by 4 is going to be $350. Now, 350. Okay? We have one heavy item, and we have 3 items that are quote-unquote lighter items. Yes, 200, 100, 200. But yet notice our mean shifts closer to 900 in order to balance everything out. It's actually greater than 3 of our items. It's not in the middle.